Welcome back, everybody, to another Digital ICT Math lesson with EdBridge Scholars. Today, we'll be talking a little bit about right angle triangles and trigonometry. So, the fundamental definition of trigonometric functions is commonly known as SOHCAHTOA. And that might sound like gibberish to you at first, but that actually does contain the fundamental definition of trigonometric functions, and that is because the way we define trigonometric functions is in terms of a right angled triangle. So if we draw our little right angled triangle here, and if we pick one of the acute angles and call it theta, then we can label these sides with different names. So for example, we know the largest side and the side that's opposite to our 90-degree or right angle. This is known as the hypotenuse. So we can label it as such. And then the other two sides, we can call them adjacent and opposite based on where they sit relative to our angle theta. So here, this side right here, this guy AB right here is sitting opposite to angle theta. So it's not it angle theta actually borders two sides, or it's sitting in the middle of two sides, but those are AC and BC. Angle theta has no contact whatsoever with this side AB, so it's actually the opposite side of angle theta, and therefore we call it the opposite side. And then the other one, which angle theta is in fact adjacent of BC, that's our adjacent side. And then we define the trigonometric function as such. Sine of theta is opposite over hypotenuse. So that's where our SO comes from. Sine, opposite, hypotenuse. Sine, opposite, hypotenuse. Cosine is cos, adjacent, hypotenuse. And TOA is tan, opposite, adjacent. So then we get SOHCAHTOA. So now we can look at an example. If you have a triangle like this, maybe let me draw something bigger. Maybe you have a triangle like this, PQR, and you're given the side lengths 3, 4, 5, very common Pythagorean triplet. Now you may have these angles theta, and you can call this angle beta, the other one angle beta. Now you might be asked what's sine of theta, and then what's tangent of beta. So the way you go about it is first you pick the angle you're looking for. So first we're looking for sine of theta. This is sine of theta. Theta is right here. And then we want to look at the definition of sine, which is opposite over hypotenuse. We know the opposite is the side that this angle theta doesn't have any contact with. So that's this guy right here, PQ. So then sine of theta is actually 4 over hypotenuse, which is right here, 5. Similarly, for tangent of beta, once again, you actually first look at the angle you're looking at. So first you pick the angle, so it's beta. And now relative to beta, so always we're picking opposite and adjacent relative to the angle. So relative to beta, now the opposite is actually no longer 4. Remember, when we did sine of theta, our opposite was this guy right here, PQ, because that is the opposite side of angle theta. But now we're dealing with angle beta, and now the opposite side is no longer PQ because angle beta does actually sit right between PQ and PR. So it's one of its neighbors. PQ is one of angle beta's neighbors. So in this case, the opposite side is actually this, QR. So it's 3 over the adjacent, which is actually PQ in this case. So it's 3 over 4. The other thing that you should try to commit to memory is some of these special values. And usually for this, I recommend making a little chart. So you can say theta, and then sine, cosine, tangent, and some of the angles that you need to know would be 0, 30, 45, 60, and 90. But most importantly, the middle three. These three you have to know. Um, and then if you fill out the chart, it ends up being so that sine of 0 is 0, sine of 30 degrees is half, sine of 45 degrees is 1 over square root of 2. You may also rewrite it as square root of 2 over 2. They're the same thing. If you divide both the numerator and the denominator by square root of 2, you end up getting 1 over square root of 2. 60 degrees, that's square root of 3 over 2, and 90 degrees is 1. For cosine, it's the same thing but backwards. You start with 1, so cosine of 0 is 1. Cosine of 30 is square root of 3 over 2. Cosine of 45 is the same as sine of 45, 1 over square root of 2. Cosine of 60 degrees is half. Cosine of 90 degrees is 0. And then for tangent, you can remember this identity, that is tangent of theta is actually nothing but sine of theta over cosine of theta, and that's because tangent of theta is opposite over adjacent. So we can just rewrite that as opposite over hypotenuse. We can divide both the numerator and the denominator by hypotenuse. So then we have opposite over hypotenuse over adjacent over hypotenuse, which means tangent of theta is just sine of theta over cosine of theta. So then you can just divide these value to get the tangent. You don't even need to memorize it. So then you end up with 0, 1, 0. Um, over here, the 30 degree, it should be half. So the sine of 30 degree is half, and then cosine of 30 degrees is square root of 3 over 2. So 1 half over square root of 3 over 2, you end up with 1 over square root of 3. For 45 degrees, they're the same, so the ratio is 1. For 60 degrees, it's square root of 3 over 2 over 1 half, so you end up with square root of 3. And for 90 degrees, you're dividing 1 by 0, but we know division by 0 is undefined, so tangent of 90 degrees is actually undefined. But make sure to just have these three middle rows memorized, and also make sure you know this complementary identity, which is sine of x is equal to cosine of 90 minus x. And this is really just a restatement of the geometry that we saw in the previous page. That is, if this is theta and this is beta or 90 minus theta, then for this theta, the opposite side is AB, the opposite side is AB, but relative to this other angle, relative to this 90 minus theta, this side is actually adjacent. So this AB is opposite to theta, but it's adjacent to 90 minus theta. And since in both cases, for both sine and cosine, you divide by hypotenuse, it ends up being that sine of theta is opposite to theta, AB, over the hypotenuse AC, and cosine of 90 minus theta is the adjacent side to 90 minus theta, which is also AB over AC. So thus you have this identity that sine of x is equal to cosine of 90 minus x. And finally, if sine of A and cosine of B are equal, so just like applying this same result but backwards, then you can conclude that those two angles must be complementary, or A plus B must be equal to 90 degrees. We can do a quick practice question here. If you have a right angle, if you have a right angle triangle and one angle is x degrees and the opposite leg is 26 and the adjacent leg is 7, then what's the value of tangent x? So we know the definition of tangent x is, so from SOHCAHTOA, we know TOA, it's opposite over adjacent, and the opposite is 26, and the adjacent is 7. So that would be our value of tangent x, which is answer choice C. The golden rule is always identify your reference angle first and then SOHCAHTOA gives you the definitions of the correct ratios, and the complementary identity, that sine of an angle is the cosine of its complement. It appears very frequently, so just remember it. Remember how it works geometrically, so you can always check it. If you can always draw a triangle and check it and confirm it, and remember those special values. As always, keep practicing, keep improving, and I'll see you in the next video.